Alright, in this video we'll go over how to implement a queue in JavaScript, but of course we have to start with the question, what is a queue? A queue is just a data structure in which the first element that was added is the first element to be removed. So let's pretend this is like a line at a grocery store. This person got in line first, followed by this person, followed by a third person. Who's going to be removed from the line first? It'll be the first person, then the next person, and finally the last one. This is a little different than a stack because with a stack, the last element that was added is the first to be removed. So let's just pretend this is a stack of dishes. Which one's going to be removed first? The last one that was added, followed by the next one, followed by the last one. Alright, so in this video, I'll quickly go over the methods in a queue, and I'll go into more details later in the video. So let's start with the method inQueue. InQueue just means to add. So in a queue, every element that's added is added in chronological order, meaning first is the letter A that goes at the bottom, next is the letter B, goes on top of that, followed by the letter C. They're just added in order. Next, let's go to the dequeue method. This is the thing that makes a queue a queue. So let's say A is the first thing added, followed by B, followed by C. What's the first thing that's going to be removed? The first thing that's removed is the first element that was added, so the letter A. So let's say after we remove the letter A, this is what the queue will look like, B and then C. Next is the peek method. All the peek method does is show you what the next element is that would be removed, but it doesn't actually remove that element. So if A is added first, and then B, and then C, and you call peek, it's just going to return to you the letter A, but nothing will change in the queue. Nothing's removed. Next, size. This one's easy. Let's say this is a queue, has 3 elements, so it has the size of 3. And finally, is empty. Let's do the same queue, A, B, C. Is empty just returns whether there are not any elements in the queue. So in this case, is empty is false because we actually have some elements. So let's start with the inQueue method. InQueue just means to add. So as I mentioned before, when it comes to queues, we add the elements in order. So let's say this is the 0th index. When I add A goes here. Next is the first index. When I add B goes there. At the second index, we'll have C, and so on and so forth. So the interesting thing about how we'll implement it is that we'll keep track of a variable called top. And what top will be is the index of the next element we're going to add. So I'll demonstrate that now. Start off with this empty queue. The index right now is 0. 0 is top because we haven't added any elements yet. So let's add one. All we have to do is reference top. So you look at top, which is 0, element goes here. Now what we do is we immediately increment top so that it points to the next index. We do this so that the next time you add an element, all you have to do is look at top. So right now top is 1, so when we add B, we add it right here. And immediately move it up to the next index, which will be 2. So just notice that the top index is always 1 more than the last element's index. Let's move on to the dequeue method. And with the queue, dequeue just means to remove. And where are elements removed in a queue? They're removed from the bottom. So let's say we added A first and then B, and then we call dequeue. The element that's going to be removed first is A because it was added first. Now let's look at this in a little more detail. Let's say A is added first. It is added at the index of 0. What we're going to do is we're going to keep track of that with a variable called bottom. Bottom will always reference the oldest element added. Right now, A is the only element added, So bottom refers to its index, which is 0. When we add b that has an index of 1, bottom will still refer to a because it's the oldest element added. Let's say we add c, index of 2, bottom is still a with an index of 0. Now, for instance, let's say we get rid of that first element. We dequeue it. What's bottom going to refer to? B, because now b is the oldest element added. The peek method is very simple. All it does is it looks at the elements in a queue and returns the element that will be returned next. So let's say we added a first, and then b, and then c. If you call peek will let you know that a is the next element to be removed, because once again, in a queue, the element at the bottom of the queue will be removed next. Size is another pretty straightforward method. It just takes a little bit of math. So all you would do is, let's say the elements added were a, b, and c, and the indices are 0, 1, and 2. Remember from before that top always refers to the index of the next element to be added. So in this case, top is 3. And bottom is the oldest element that was added, which is a. So to calculate the size, all you're going to do is take top and subtract bottom from it. So in this case, top is 3. You would subtract bottom, which is 0, and that'll give you the size of 3. There are a couple different ways we can implement isEmpty. The first way just takes a little bit of math, or actually just a comparison. All you would do is you would check the index referenced by top against the index referenced by bottom. And if they're the same, then the queue is empty. But the much easier way is to realize that we just calculated the size. So all you'd have to do is reference the same size method we just created and do a comparison. Does size equal 0? Now we get to the code. Remember, we need one variable, we'll call it top, that keeps track of the index of the element that's going to be added next, and another variable, bottom, which keeps track of the index of the oldest added element. So we go to the constructor and say this.top equals 0, because we're starting at the 0th index, and since it's empty, the bottom is going to be the same. So top and bottom, of course, the same in an empty queue. Next, we need a data structure that actually holds the values. So what we'll say is this.storage equals an empty object. And I'll just give you a representation of what that's going to be. So let's say we want to add the letter A like we've been doing. This will look like this. So at index 0, we have the letter A. And if we, let's say, add another one at index 1, we'll have the letter B. All right, let's move on to the enqueue method. Remember, enqueue just means add. So in the data structure, all we're going to do is say this.storage, this.top, because remember the top always represents the next element, the index of the element that's going to be added, equals value. And then we always increment the top afterwards to get it ready for the next element that's going to be added. So this.top plus plus. Now let's go to the dequeue method. This one's a little more involved, but I'll walk you through it. It's really not that bad. With dequeue, you actually have to return the value of the element that you're removing. So what you do is you get a reference to that value. We'll call the element the removed element. So let removed element equal this.storage. And what's the name of the element? It's always going to be the bottom element. So this.bottom. Now that we saved a reference to its value, we need to delete the element itself. So we have a reference to the value, but now we're going to delete it from the data structure. So delete this.storage, this.bottom. Next, now that we've deleted the element, we have to increase the variable that represents the index of the bottom element. So stick with the example we've done before. we had initially the elements A with an index of 0 and the element B with an index of 1. Since we're deleting element A that has the index of 0, we need to increase the variable bottom so that it moves up to element 1, so that the next time when we want to remove an element, it's going to remove the correct one. So this dot bottom plus plus, and then finally we just return the value of the element that we're removing. So remove element. One last thing that we should do is first we should check if the queue is empty, because you can't dequeue anything from an empty array. So if, and I haven't actually implemented this method yet, but I'll do that in a second. So if this is not empty, then execute all these steps. Okay, peek. As we said before, peek just returns the next element that's going to be removed, aka the element at the bottom of the queue. So we just do return this dot storage, this dot bottom. Size just returns the size of the array. So return this dot top minus this dot bottom. And finally empty. Now that we know the size of the array, all we have to do is test to see if the size is 0. If it's 0, it's obviously empty. So return this dot size equals 0. All right, so that's actually it for the implementation. Let's test it out. So down here, we can just take a quick look. I'm going to make a new queue, print out the size of the queue, make sure is empty is working. Then we're going to add the elements A, B, and C. Check the size. The size should be 3 because we just added 1, 2, 3 elements. And then to make sure the peek method is working, we'll call queue.peek. So when we do this, it should return the value of the next element that will be removed, which is A. Remember, peek doesn't actually remove anything. It just lets us know the one that would be removed. So let's run this. Move it up a little bit. Okay, so the queue initially has a size of 0. That's correct. It's initially empty, yes. And then we added the 3 elements, so the new size is 3. And then the next element to be removed is A, which is correct, because it's the first one that we added. Let's just test it a bit further. What we'll do is actually use the dequeue method. So this should remove the element A, and then we'll log what we see after the dequeue, so the size of it. Initially it was 3, so of course it's going to have a size of 2. And then we'll use the peek method, which again shows us the next element to be removed. Since we've already removed the letter A, it should return the letter B. Okay, so size after the dequeue started off as 3, but we removed 1, so now it's 2. That's correct. The next element to be removed after dequeue is B. Perfect. So remember that if you want to see the code or download it, you can just check the description below.